So hello everyone, welcome back. Today we have one interesting coding problem from LeetCode problem of the day, which is minimum number of seconds to make a mountain height 0. So what is the problem? Problem is we have given one mountain and its height h. Along with that, we have some multiple workers, each with their own speed. They are all simultaneously chip away at the mountain. Means this is the mountain and they have workers which are chopping this mountain into pieces such that the mountain height will become 0. So this worker is performing its task on its own speed. Similarly, all our workers are performing. So we have given their speed and the mountain height, and we have to find the minimum seconds to make the mountain height 0. Let's see what is given exactly. So we have given mountain height like 4, 5, 6 in units. We have given mountain height in units. So this is the H unit. Along with that, we have given worker times. This is an array. What is that? Worker time. So worker times. It is in array 1, 2, 3, like that. 1 means, 2 means, 3 means. That's what does that mean? So if array is like this 1, 2, 3, so 0th worker can perform chopping of 1 unit of mountain in 1 second. Similarly, chopping of 2 units of mountain out of its height. Height is also given. If height is 4 units, then 1 unit can be chopped by worker 0 in 1 second. In 1 second. Similarly, for second worker, which is 1, 2, 3, then first worker can chop 1 unit of mountain in 1 second. First worker can chop this mountain height of 1 unit in 1 second. Similarly, for second worker, it can chop 1 unit of height in 2 seconds. Third worker can chop 1 unit of height in 3 seconds. This is what given. So you will see say that each worker is taking 1 unit of time, 1 second time to chop 1 unit of height. Then it will take 2 unit of time to chop 2 unit of height. But this is not true. Suppose they have to find how much time worker will take to chop X amount of height. To find that, here is the formula. How long does it take a worker to reduce a height by X? It is given by W. W means the given array of workers times. This one is for specific worker. That W is taken here. Along with that, how much height you want to chop. If you put that in this formula, you will get minimum time or total time required to chop mountain of X height. Hope you get that. So what is given again? Mountain height and worker times. Worker time means, suppose worker time is 1, 2, 3, then 0th worker can chop 1 unit of height in 1 second. So this is time required to chop 1 unit of height. Simple terms. In simple terms, to chop 1 unit of height, 1 unit of height, it requires, I'm sorry, here it should be height. One unit of height. To chop 1 unit of height, the worker take 1 second. Similarly, 1 unit of height, worker take 2 seconds. Similarly, 1 unit of height, worker takes 3 seconds. So this is what worker time is. So, and this is the formula to find how much time does that worker take to reduce height by x. For 1 unit of height, it will take 1 second, no doubt. But for 3 unit of height, for 4 unit of height, to find that 4 means here it is x. Put that x in the formula along with w. W is for 1 unit of height. Value for 1 unit of height. You will get time required to reduce the height of mountain by x. Here, example is there. Here, a mountain height is 4. So, let's suppose mountain height is 4. Here it is that mountain with height as 4. Right? So height of this mountain is 4 units. And we have to find, and also we have given worker times 211. Suppose this is first worker. This is second. And this is third worker. Helmet. And he's okay. They are trying to chop this mountain such that its height will become 0. Let's see what is given. 211 means first worker can chop this mountain 2 unit in 2 seconds. 1 unit in 2 seconds. So suppose you want to chop this part. It's 1 unit part. Alright, to chop this, it will take 2 seconds. 2 seconds to chop this unit of part. 1 second to chop this unit of part. And 1 second to chop this unit of part. So most efficient workers are these. This is insufficient because it is taken 2 seconds to chop 1 unit of part. Hope you understand this. Let's see the key insights, which will be better approach. So brute force is like what we are doing here. We are splitting height among the workers. Like say, let's say this height is chopped by this worker, this height is chopped by this worker, and this height is chopped. The remaining height will be chopped by this worker. Otherwise, we will do permutation and combination of heights. There are 4 levels, 4 heights total. So we will give 1 unit of height to him, 2 unit height to him, and remaining 1 height to him. So this is one, but it is very slow because we have to find all the heights required to chop and distribute them among these workers. So it is very slow. So we will choose another approach, which is smart approach, in which instead of deciding who reduces how much height, here we are deciding how much height will be treated among each worker. We will decide, can all worker together finish this within t seconds? So this is the This is the way, smarter way to solve this problem. If we ask, can these all workers chop this mountain in T seconds? This is the question which we will ask. Instead of asking, can we split this mountain height among them? Like that. So the question is, how to find this T second? So here is the algorithm, how we can check that. So first, what we will do, the minimum time which can be possible for worker to chop this mountain is 0 seconds. In 0 seconds, we will chop this all mountain. Let's say, and the highest is, if we give all the tasks to one worker to chop this mountain, then it will be highest time or maximum time required to chop this mountain. So which is here 2 seconds. This worker taking 2 seconds to chop 1 unit of height. This is taking 1 second to chop 1 unit. This is taking 1 second to chop 1 unit. So using this worker work time, we will find highest possible time required to chop this mountain. And so we will get a range. What will be range from 0 to T? This minimum time will be between this 0 and T. So we can find the minimum T required using doing binary search between this range. So do the binary search. First find the middle part of between this, and is this mid time is enough or not. We have to create another function to find is this the mid time, the time which we found between the 0 and T is efficient or enough to find the minimum time or not, or to chop this mountain so that the mountain height will become 0 or not. So after asking this function or getting the answer, we will, if it is possible, then what we will do, we will try to minimize time. So low will be 0 and highest will be mid, and we will do binary search between these. So let's see how we can find that is this T time is enough or not to chop this mountain to 0. So that is the only question which remains. Is this T time is enough or not? To find this, we have to first find how to find the maximum height per worker. So suppose we have given T. So we found that T here, that we have to find is T enough or not. So to find, as these are working simultaneously, first we will find for how much work he can do in T seconds. So T we have found in binary search. So how much height he can chop in T seconds. We will get that here using this function. How will this quadratic equation, how we got this quadratic equation? So here we have formula to find T, how much time it took to reduce height by 1. It is given formula here. W into x plus 1 divided by 2. So using this formula, we have got time. But now we have to reverse that. We have to find x. We have to find x by given time. This time we got from binary search. Right. So we have got T, and we have also now know how to find x, maximum x chopped by worker in time T. So we will get first worker time, first worker chopped height FCX, second worker chopped height x1, and third worker chopped height x3. adding this if it is coming as greater than mountain height. Suppose it is come as 7 and mountain height is 4. So it is possible that we can chop the mountain in t time. So we will reduce the t using binary search formula, and we will minimize the window of low and high. And again we will find mid, and we will ask again same question, can this time is enough for chop mountain to height 0? So I hope you understood how we got the maximum height a person or worker can chop in given time t. So this is that formula. Next, we have, let's step by step solve one example so that we will understood how we are solving this type of example. So in main function, we are creating one function which is minimum number of seconds. This is our aim, to find the minimum number of seconds with the help of mountain height and worker's capacity or worker time. It is time required to chop 1 unit of height. So function called this helper function. From main function we have called this helper function. This is given to 1 which is worker times and height of mountain is 4. So this same example is here. Now we will move to next time. So it is for comparing with the maximum time. We have by default we have stored this minimum value. Next we will iterate through this worker time and find, as we have find this is insufficient, so the maximum time will be taken by this worker will be highest time possible to chop mountain, right? Highest time possible to chop this mountain to height 0. So let's see, we are iterating through this loop. We have h as mountain height, which is 4 here. Then we will calculate cost. So what is cost? Maximum time required for this person to chop this all mountain, which came as 20. Using this formula, W into, as we saw previously, as we expressed 1 divided by 2. This was the formula. Using the same formula, we have found that cost required for first worker is 20. So we will store that as max time and continue iterating to next worker. Next worker is taking 1 second to chop 1 unit. Let's check how much it takes. The cost of second worker is 10. So it is taking 10 seconds to chop all the mountain. So this is more efficient. So it didn't come as a max time. Max time is given by this worker. Similarly, we will check to third person. Third person is also have same work time. So no change will happen here. We will move to come out of loop and assign low as 0 and max time as 20. So we will iterate between 0 to 20. See, this is below of our binary search. This is high. So for binary search, we will find mid as usual, and we will ask question that can we finish cutting this mountain or chopping this mountain such that its height becomes 0 with time as 10. Let's how this version works. So we are asking the same question. The question is, can we finish chopping of this mountain in time 10 seconds. So we'll move to this function now. Can finish time is 10 seconds, height is 4 unit, and worker time is also given. The total is 0. So what is total represent? Amount of units chopped by these workers in provided time. We will move through each worker and check how much he can chop this mountain in given time. So it comes as 2 units. He can chop 2 units in given time. Given time is 10. This formula is already given. We have found with finding on maximum height in given time t. Where time is 10. So what we are doing here, after finding the maximum possible height, as this is quadratic equation and we are square rooting, it usually get plus or minus 2 or plus or minus 2 after rounding the round solution. So we will adjust the x such that we will ask the question like, can we increase the x? This is the formula to find the time required by worker W in given x. In given x is maximum height. So we found that x is using this formula, but we are saying if we can increase the x, can we increase x by 1 or not? This condition is asking, can we increase the x by 1 or not? So it is saying that if we increase x by 1, it will take 12 seconds, but our time limit is 10 seconds. So it will not execute this condition. So it will now check is current x is exceeding the time 10 or not. It is checking for current x and it is checking for increase the x. Hope you understand this. And as this is 6 and this is 10, it is possible. So we will not decrease our x. We will add that in total. So total will 2. Now this worker chopped this mountain of 2 units. The remaining is 2 units. Let's see how the workers can do their job or not. Is total is greater than height? Height is 4 units and total is 2. So now it is not true. It will go to next worker. How much he can chop? He can chop 4 units, as this is more efficient than this one. So he can chop 4 units. We will check, can he chop more? If we increase x by 1, here it is 4, but if we increase it by 1, it is coming that it took 15 seconds. So 15 seconds are greater than 10. So we will not execute this condition and will come out of it. Similarly for this also, x is possible, time is possible to chop x amount of mountain. So we will add that into total x. So total become 6. Test it was 2 and this 4 is get added and now it become 6. So now already satisfied height. Height is 4 but chopped height is 6. So it is true that we have chopped mountain to 0. So we will return true. And now is the value true? Yes, true. Then we will assign high as mid. So mid value was 10. So now we will set high as mid. So high is 10. Now low is 0. So you will find the minimum time between this low and high. The same process. And again we will ask the same question. Now mid is 5. Is it possible to chop this mountain within 5 seconds or not? Then function will get called and we will execute. You can execute this instruction. If you want to see execution for each instruction, you can use this tool. After clicking, it is calling the minimum number of seconds function. It calls and it executes each instruction. So you will track each instruction how it is executed. But this is the tool you can use. That's it. Thank you.